Hello, welcome to another interesting mathematics class. My name is Eke Omoji, your mathematics friend and tutor. Today we shall be continuing our class on quadratic equation, and we'll be talking about how to apply the formula method to solve quadratic problems. By the end of this class, you should be able to prove the formula method, and also you should be able to apply the proven formula method. The formula method for solving quadratic problems to me is the simplest, because all you need to do is to find the coefficient of x squared, the coefficient of x, and then the constant. Once you do that, you're good to go. The quadratic formula is so simple and powerful. Its power and simplicity gave it the nickname, the almighty formula. Given a standard quadratic equation of the form ax squared plus bx plus c is equal to 0, all you need to do is to identify the values of a, b, and c, and then substitute their values into the equation. X is equal to minus b plus or minus square root of b squared minus 4ac divided by 2a. So, how did we get this formula? Let's say we have a standard form of quadratic equation as ax squared plus bx plus c is equal to 0, and we are to prove the quadratic formula. How do we do that? The first thing we need to do is to identify the coefficient of x squared, the coefficient of x, and the constant. Remember, now coefficient of x squared is equal to a, the coefficient of x is equal to b, and then the constant is equal to c. Step 1, divide through by the coefficient of x squared, which is a. We had this original equation, ax squared plus bx plus c is equal to 0, right? This was a given standard equation. And now we have to divide through by a. So we divide this by a, divide this by a, divide this by a, and also divide the 0 by a. This will cancel this because a divided by a is something as just 1. So we would have 1x squared. Then plus bx divided by a plus c over a, and that will be equal to 0 over a. Remember, 0 divided by anything will still remain 0. So 0 divided by a will still be 0. So now we have x squared plus bx divided by a plus c over a is equal to 0, and that we will call our equation 1. Our step 2. Move the constant, which is c over a, in equation 1 to the right-hand side. Remember now our equation 1 is x squared plus bx over a plus c over a equal to 0. We call this equation 1. Remember that? Now we want to move c over a to the right-hand side. How do we do that? Simply subtract c over a from the left-hand side and the right-hand side. When we do that, we would have x squared plus bx over a plus c over a minus c over a equal to 0 minus c over a. Right? So c over a will cancel c over a because anything subtracting itself will be 0. So we'll now have x squared plus bx over a is equal to minus c over a. So let's call this equation 2. Please note that 0 minus c over a is equal to minus c over a. Okay, our step 3 is divided into actually 3 stages. So let's start with the first stage, which is divide the coefficient of x, which in this case is b over a, by 2. Remember our equation 2 was originally x squared plus bx over a equal to minus c over a, right? This is our equation 2. And we are asking to divide this by 2. So we'll now have b over a divided by 2. I'll just say 2 over 1. It's the same thing. Therefore, we'll have b over a times 1 over 2. Why this? That is because a divided by b divided by c over d, that would give me a over b times d over c. This is from your elementary mathematics. Therefore, now we know that b over a times 1 over 2 will give us b over 2a, or simply 2 times a. This is what we have. Next, let's square the result we obtained in 3i. The result we obtained in 3i was actually b over 2a. You remember? So we just have to square this. The last stage of our equation, the last stage of step 3 will now be to add the result we obtained in 3ii to both sides of equation 2. Remember, our equation 2 now is x squared plus bx over a and equal to minus c over a, right? This is our equation 2. So we want to add what we got in 3ii. We got b over 2a and we squared that. So let's add this to both sides of equation 2. When we do that, what we would have is x squared plus bx over a plus b over 2a all squared, and that will be equal to minus c over a plus b over 2a all squared. So now let's call this equation equation 3. Now let's complete the square on the left hand side of equation 3. Remember, our equation 3 is x squared plus bx over a plus b over 2a all squared, and that's equal to minus c over a plus b over 2a all squared. This is our equation 3. So by completing the square simply means we should collect square terms on the left hand side. So let's do that. We now have x plus b over 2a all squared, and that should be equal to minus c over a plus b over 2a all squared. Let's call this equation 4. Please note that x plus b over 2a all squared will give us the same thing as what we have here if we expand it. What I'm saying is x plus b over 2a all squared is equal to x squared plus bx over a plus b over 2a all squared when expanded. Our step 5 now is to take the square root of both sides of equation 4. Remember, our equation 4 is x plus b over 2a all squared, and that is equal to minus c over a plus b over 2a all squared. Taking the square root of both sides simply means we should take the square root of the left-hand side and the square root of the right-hand side. Please take note, when we do this, the square root will be cancelled by the square here. So we now have x plus b over 2a, and that is equal to square root of minus c over a plus b over 2a all squared. Now the square root and the square on the left hand side cancelled out, right? But why didn't that happen in the right hand side? Well, remember, from SOD, square root of a plus b is not the same thing as square root of a plus square root of b. You know that, right? So if we do that here, it will not work. That's why we cannot take out the square root on the right hand side. So now let's call this equation equation 5. Now step 6, make x subject of equation 5. Remember, equation 5 is now x plus b over 2a, and that is equal to minus c over a plus b over 2a all squared, and everything is wrapped in a square root. To make x subject, subtract b over 2a from left hand side and right hand side. When we do that, we'll have x plus b over 2a minus b over 2a, and that is equal to minus b over 2a plus or minus square root of minus c over a plus b over 2a all squared. Now, b over 2a would cancel b over 2a, and we'll be left with x is equal to minus b over 2a plus or minus square root of minus c over a plus b over 2a all squared. I know you will be wondering why this symbol here. Remember that if we have 2 raised to power 2, it will give us 4, right? Also, if we say minus 2 raised to power 2, it will still give us 4, right? So that plus or minus is telling us that whether it's plus 2 or minus 2, when we square them, we'll still get 4. Okay, so let's continue. The last equation we had was x is equal to minus b over 2a plus or minus square root of minus c over a plus b over 2a all squared, right? Okay, let's take the LCM of what is in the square root. Now let's expand what's in the bracket first. So we have x is equal to minus b over 2a plus or minus square root of minus c over a plus b squared all over 4a squared. How did we arrive at that? Please remember, if you have b over 2a and you are squaring that, it's the same thing as saying b over 2a times b over 2a. That's how we arrived at this. Now we have x is equal to minus b over 2a plus or minus square root of minus c over a plus b squared over 4a squared, right? LCM of a and 4a squared is 4a squared. So when we take the LCM of what we have in the square root, what we would have is now this. Please let's do it outside, then we'll put it back in there. What we'll have is minus c over a plus b squared over 4a squared, and they have their LCM as 4a squared, right? Now 4a squared divided by a would give us 4a. 4a times minus c will give us minus 4ac. Next, we would say 4a squared divided by 4a squared. It will give us 1. 1 times b squared will give us b squared. Right? So let's replace what's in the square root with what we've just found here. We'll be using this to replace what we have here. So what we have now is x is equal to minus b over 2a plus or minus square root of minus 4ac plus b squared all over 4a squared. Okay, remember from the last equation, what we had is x is equal to minus b over 2a plus or minus square root of minus 4ac plus b squared all over 4a squared, right? Now, let's go back to our friend SOD. Do you remember that from SOD, square root of a over square root of b is the same thing as simply saying square root of a over b, right? So we would apply that here. When we apply that, we have x is equal to minus b over 2a plus or minus square root of the numerator, which is minus 4ac plus b squared all over square root of 4a squared. Also, we know that from SOD, square root of 4a squared is the same thing as square root of 4 times square root of a squared. Of course, you now know that we would have square root of 4 to be 2, and then square root of a squared will be a. So we now have 2a. So, substituting this back into the equation, we would have x equal to minus b over 2a plus or minus square root of minus 4ac plus b squared all over 2a. So going on, we'll rearrange what we have in the square root. So we now have x is equal to minus b over 2a plus or minus square root of b minus b squared, b squared minus 4ac, and that will be divided by 2a. So simply note that a plus b is equal to b plus a from your law of commutation. Now for what we have, LCM of 2a and 2a will still be 2a, right? So what we now have is x is equal to minus b plus or minus square root of b squared minus 4ac divided by 2a. Let's call this equation 6. Note, this equation 6 is what we call the almighty formula, or the formula method of quadratic equation. Equation 6 is called the almighty formula, and as you can see, it's the same thing as what we've just proven. X is equal to minus b plus or minus square root of b squared minus 4ac divided by 2a, where a is a coefficient of x squared, b is a coefficient of x, and c is a constant. Like I said, all you need to do is find the value of a, the value of b, and the value of c, and substitute them into this equation. The almighty formula is also written as x is equal to minus b plus or minus square root of d divided by 2a. The d there stands for the discriminant, and is simply the same as what we had initially, which is d equal to b squared minus 4ac. What is the significance of this discriminant? The discriminant tells us what to expect from solving a quadratic equation. What do I mean? If the value of d is less than 0, it means there are no real roots. So that means we can't find the roots because we would have a negative value in there. What do I mean by that? If d is less than 0, as you have here, it means you have square root of a number that is negative. And you cannot find that. But if d is equal to 0, it means we would have two roots, but they will be the same. So there's no need, we just say one root because the two roots will be the same. That is because square root of 0 would still be 0. And so the equation reduces to b over 2a. Finally, if d is greater than 0, we would have two distinct roots. In that case, we can find x1 and then x2. Let's try an example. Example 1, solve the equation minus 5x squared plus 12x plus 5 is equal to 0 using the quadratic formula. Step 1, identify the values of a, b, and then c. A from our equation here is minus 5, b is 12, and c is 5. Right? So let's put that into the equation we know before now. Let's first of all test the discriminant, which is our second step. Testing the discriminant means we will now say d is equal to 12 squared minus 4 times minus 5 times 5. Minus 5 times 5 is minus 25. Then when we multiply it by 4, it will be 100 because of this. Remember, minus times minus will give us plus. So we would end up having 12 squared minus, and then this minus, it will turn to plus. That's why we have 244. Step 3, substitute the values into the formula. X subscript 1, 2 is equal to minus b plus or minus square root of d divided by 2a. When we substitute the values into the formula, we would have this. x1 is equal to minus 12 plus square root of 244 divided by 2 times minus 5. And then we'll solve that through, we'll get x1 is equal to minus 0.362. x2 will be minus 12 minus square root of 244 divided by 2 times minus 5. Solving that through as well, we'll get x2 to be 2.762. Please take note, the only difference between the two is that x1 takes off the positive while x2 took the negative. So the only difference between the two of them is that x1 has the positive, whereas x2 has the negative. Let's try another example. Determine the solutions of the quadratic equation x squared plus 4x minus 6 is equal to 0 using the quadratic formula. Solution. Remember, the first thing we need to do is to identify the values of A, B, and C. By doing that, we have the value of A to be 1. There is an invisible 1 here. The value of B to be 4. And then that of C to be minus 6. Our step 2 is now to substitute the values into the formula. So we'll now substitute the value of B to be what? 4. The value of B here will still be 4. The value of A will become 1. And then the value of C would be minus 6. When we do that, we would have this. X subscript 1, 2 is equal to minus 4 plus or minus square root of 4 squared minus 4 times 1 times minus 6. Remember, this occurs again here. Minus 4 times 1 times minus 6 will give us minus 4 times minus 6, right? Just note that minus times minus will always turn to what? Plus. By solving this, you will now have minus 4 plus or minus 6.32 divided by 2. Next is to look for our x1, which will take up the positive sign, and then our x2, which will take up the negative sign. By doing that, we'll have x1 is equal to minus 4 plus 6.32 divided by 2, and then solving to get x1 is equal to 1.16. Doing that to x2 as well, we have minus 4 minus 6.32 divided by 2. When we also solve that, we'll get minus 5.16 as our s2. Having solved these examples, we've come to the end of this class. But before we go, let's take a look at the things we've learned. First, we learned that formula method is obtained from completing the square method. That means we have to solve through the process. Next, we also learned that the formula is given as x subscript 1, 2 is equal to minus b plus or minus square root of b squared minus 4ac divided by 2a. And b squared minus 4ac is referred to as the discriminant. We also learned that in solving quadratic equations using the formula method, all you need to do is to identify the value of a, b, and c, which are the coefficient of x squared, the coefficient of x, and the constant, respectively. Next, we need to do is to substitute these obtained values into the equation. Also, we learned that the value within the square root is called the discriminant. Finally, we also learned that we use the formula method to find the solutions of a quadratic equation by solving for x. Now, let's try some test questions. Question 1. What is the value of the discriminant in the following quadratic equation? 2x squared minus 6x minus 5 is equal to 0. A, 36. B, minus 6. C, 13. D, 76. Which of them is the answer? The answer is D. Question 2. Using the almighty formula, find the solutions to the equation 2x squared minus 3x minus 9. The answer is B. X is equal to 3 and x is also equal to minus 3 divided by 2. Thank you for your time. I hope you can now solve quadratic equations using the formula method. Till we meet again. Bye-bye.